Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode we're going to be picking up where we left off with the trajectory calculator, or the trajectory system rather, however I labeled it, I forget. And kind of going over some of the changes that I made since the last video. I left a comment on the last video saying that I looked over the scripts and they were kind of wonky. That's still true. But I'm going to leave that video up, I think, and I'm going to leave a big annotation at the head of it to say, hey, this is messed up. You might want to head over to this other video, this video currently that you're watching right now, weird, and watch this one instead. I'm going to be doing basically what I did in the last video, where I go over the script and all that jazz and talk about all the different variables and things, but this script works leagues better than the other one ever thought it could. Yeah, so jumping right in, I want to say that this whole trajectory system works really well for what this does, but depending on the nuances of your game design or your mechanics and whatever you're building, it may or may not function to what the effect that you need. This is just a way that I have found to do it, and I would like to, as I go into this, I'm going to talk about what got screwed up for me, like where I got stuck and how I overcame that being stuck, because I have a feeling a lot of people get stuck on things and they don't know what to do when they get stuck, and I have a really weird, almost scary way of getting over that, and I'd like to share that with you guys and explain what happened to me. So yeah. So the first thing that I want to say is that this this whole system is broken down into 3 scripts. So I have the trajectory calculator, which is here, and I have the trajectory controller, which is here, and then I have a third script called the trajectory projectile, which is on my trajectory projectile prefab. The idea being that I want to create this arc, and I want to be able to have inputs guide that arc, and I want that arc to then be fed into a projectile that then follows that arc. There's a lot of having chatted with a couple people about doing this, I got a lot of responses like, well, why don't you just give it a direction? Like you draw the arc, and then you give it a direction and a force, and you just tell it to go. Like you can just use the Unity rigid body system to do all the math for you. You don't have to figure anything out. The main reason why I didn't want to do that because it is something you can do. Like you can pull back on the controller, and you can launch a rigid body object out into space, and hopefully it'll follow the same arc as what you laid out. But maybe it won't. Maybe maybe the math that you're doing on your display arc isn't quite right. So instead, I wanted everything to be 100% controlled. I wanted to guide my projectile along the same arc that I am displaying, because I don't want misinformation to happen. I want everything to be exactly how I want it to be. I don't want to just throw caution to the wind and let physics take over, especially physics calculations that I don't know exactly how they work. Like that doesn't seem right to me, especially from like a game design standpoint. I want full control over that. So I went kind of crazy with it, and yeah, let's start. So the first things first. I still have this this arc builder. Let's see here. We want to go 1 and 1, and we want like a power of 1.6 is what I think I had. Yeah. So we still have this thing that generates an arc for us, and the main things that are different is I've added drag, which I didn't have before. Drag does this. It over the lifetime of the arc, it will apply a negative X. Well, it applies it negatively towards the direction that we're firing it from, up to a up to 0. So like if I launch it this way, then it'll apply a negative force that way up to it being 0. So the way that this is displayed is like these. So you'll see that this eventually becomes a flat line. This is just going to go straight down. That's kind of what drag does. So I'm saying that I only want drag along this one axis because that's kind of the stylized thing that I want to go for. I'm making a 2D system here. Well, a system made for 2D that could possibly be adapted to be 3D very easily. That's kind of what I'm going for. So this particular system works primarily in 2D. So as the object is going, as the arc is moving along this way, it is being shortened along that axis as well. So the more drag you apply to it, the more it will be cut short and begin moving at a very sharp downward angle. Yeah, and if you apply negative drag, then you're going to make it go like crazy far. Yeah, which we shouldn't do. I had to set to 0.05. That's what seemed like it worked well. Typically, this is going to be 1, 1. I have to do that when it's paused, otherwise it freaks out. 1, 1, and then I unpause and it rebalances. This is a really, really interesting thing that I'm doing with this, and I'll talk about that more, but it's basically a normalized vector. It's becoming a direction vector. A direction vector is it's something that totals 1 in one way or another, and it doesn't look like it does. Like if you add those two together, it doesn't equal 1, it equals like 1.4 something something something, because yeah, the directions are weird. Basically none of the values can be over 1 is kind of how a direction works. I don't even know if that's right, but directions look funny and they don't add up right at first glance unless you know how they work. So this is a direction vector, so if I increase this one, the other one goes down. Yeah, that's all. And I can show you how I'm doing that in a minute. But just know that if I pause it and I put 1 and 1 in, then if I unpause, it's going to equal out to 0.7, 0.7. And that's effectively going to be at a 45-degree launch angle, so up this way, like that. All right, so this is creating an arc. This is what the trajectory calculator does. It has a collision mask for default and environment because our cubes are set to default layer. So's my sphere, I think. Yeah. It does not calculate this guy because this guy is set to launcher. I could, if I wanted to, tell it to use launcher, but that would be silly of me because it could or could not read a collision on that, and that would be bad. But yeah, so I have a collision mask. It reads collision. It does, whether you believe me or not. There we go. So there's it reading collision. And I have a number of points. So this is how far I want it to go. If I decrease or increase this, it will cut the number of points, kind of like a distance. I have it set to 60 for now, just because I do. And then the amount of power is how hard I'm shooting the thing. So what is my input that I'm... So what is the amount of gunpowder in my cannon effectively, right? And like how strong am I shooting this thing? And then drag, I kind of talked about drag. Launch vector, I talked about launch vector. Gravity is gravity. So if negative gravity, I'm going to curve up because I shot and gravity is expelling me away. If gravity is 0, in theory, this should just be a straight line. Let me move that guy out of the way. And you'll see that it's a straight line because I never go down, right? Normally, gravity would be set to 9.8. You'll notice that if I do that, it's pretty intense. If I wanted... trying to think here. If I do 0.98, I might get a more realistic gravity. Unfortunately, realistic gravity isn't necessarily all that fun. Unless I start doing, like, high power. The problem here is that the higher the power, the farther away these points are. And then you start to get kind of a choppier movement arc. Because, you'll see this later. This is the problem that I kept having when I was... this is a related issue to the problem that I was trying to solve. I was trying to get the arc to subdivide, which is to say smooth out. So I would be adding points in between each one of these points to try to kind of smooth the arc out so that I had a smoother fluid movement of my projectile. And it just ended up being a mess. I kept feeding this arc through various equations, and it never came out quite right. And in the end, it was just a kind of a huge waste of time. So what I ended up doing instead was I just ended up reducing the gravity down a lot to make it function as I wanted instead. and then I could decrease the amount of power that I was feeding into it, and I got a much smoother arc out of it, and I was much happier with that. And it functions as you would expect it. So effectively, I have a fake gravity that uses lower power so that I can get the arc that I want rather than the arc that it should be, which is probably better anyway, because again, approaching this as a designer, you want full control over everything, and this is more of that full control. I hope that makes some sort of sense. Game design is a weird thing because you never want to make a game realistic if it hinders the gameplay, right? Like if a Call of Duty game was realistic, when you got shot in the leg, you would lose because you would just be, crawling around on the ground, and you'd eventually get evac'd, and then you spend the rest of the game in the hospital. None of that would be fun. So instead, you are Superman, and you recharge, and you go back out into the field, and it's kind of like that, but that's kind of a more exaggerated example, right? This is just a simple little gravity system that I'm now changing to be not as realistic because I don't like the realistic nature of it. I think the realistic nature of it hinders what I'm going for, so I'm going a little bit more abstract with it. That's fine. Yeah, so anyway, that is gravity. And the debug is whether I want to see this arc or not. Yeah. So let's see what I have here. So the other things are the calculator right here, which is going to do this guy, which I think you guys have seen in the last video if you've watched it. This is basically an in-game representation of my debug arc up there. So you can kind of see the two moving in tandem. They are the same, and if I move really quickly, you can kind of see them tearing apart from each other because the debug is run at a different time when rendering the frame than like in-editor frames are different than in-game frames. So yeah, that's kind of why you're seeing that, if that makes sense at all. And then when I let go, I fire a little projectile that follows that arc, and then it explodes. So yeah, and I can arc things up and over like that, and kablooey. And if you notice over here, if I do something like that, where I arc this up, and if I just move this a little bit like that, you'll see that the projectile actually continues going for quite some time and then disappears. And the reason why I had two options there, right? I could either let it keep going like it is now, or I could blow it up or delete it as soon as it hit the end of the arc. But the problem is I have no way of knowing like how much power people are going to be applying to my arc, which is why I also added this nice little like fade out on the end of my arc display, because I don't know if people are going to say do something like this, or if they're going to do something like this. So I want I don't want them to see behind the curtain, I want them to assume that projectile just went off somewhere and hit something. And I don't want the projectile to I don't want them to know exactly what's going on here, if that makes any sense at all. So I'm kind of fading the arc out, and I'm moving the projectile beyond the arc. So it doesn't follow the arc. It follows the arc exactly up until the very end, and then it just keeps going in whatever direction it's going in. It could follow gravity. I could have added a lot more stuff to it, but that's just to get it off the screen so that the player doesn't see it, All right. So anyway, this is the whole system. You click on this thing, you drag it back, and the distance away from where you dragged it, adds power. The distance from the clicked object to the cursor is the power, and then the distance, the direction that my cursor to the object is the direction that I am shooting it. So the distance from here to here is the power, and then the direction from here to here is the opposite direction of which I'm firing. Hopefully that makes some sort of sense. So yeah, that's an overview of the whole system. The controller has a couple variables. It has a display, which is parented to this, which is a line renderer. I can talk about that in the next video. This is going to be a two-part video. I'm already halfway through this one. yeah, so I have a mouse button for how I want it to be read. So if I want this to be mouse button 1, it'll now not work with left click, but it'll work with right click. If the input to power is the amount, the distance from here to here in pixels is then multiplied by this and then fed in as a float value to power. So if that makes any sense at all. I didn't want to, like, if I move 50 pixels, then I'm applying a 50 power, and that's a lot of power. So instead I want to multiply that by 0.5, and then I have a 0.5 power. That's a much more reasonable number for my power system, considering that 1.5 is a lot, right? And as a matter of fact, I have a max power on here. What I ran into was if I came into here and I really cranked this thing, it would just, the spacing on my arc would be astronomically high, and I would still get jittery movement and stuff like that because the object, my projectile, is moving along that arc. It's like I don't know, a very, very, like, angled arc, I guess, because one segment took up the entire screen. So it would move in a very straight line, and then it would suddenly change direction and then move to another straight line, and that was just a mess. I've added some stuff to kind of compensate for that and reduce the, or to add some smoothing in across that arc with the projectile, which I'll talk about. It was that was a big revelation solution thing that I had like this morning. But yeah, so the max power is a cap on the amount of power output from this. So I can only ever apply 2 power. So if you notice down on my trajectory calculator script down here, when I do that, I max out at 2, and it never goes higher than 2. I can go less than 2, but I can never go higher than 2. And 2 will get me more than off the screen and doing what I need to do. I shouldn't ever need more than that. So that's kind of what that is. And if I do need more than that, I can increase this number. It's not that big of a deal. Then the last thing I have is a link to my projectile prefab, which is the thing that I'm firing, and then that handles all of the explosion effects and it moving along the arc and all that jazz, and its own collision and all that stuff. So all 3 of these kind of work in tandem together. The trajectory calculator being the thing that makes the arc, the controller being the thing that handles the input and then generates the arc based off of those inputs, and then the controller also being the thing that spawns the projectile and feeds the arc to the projectile and kind of makes everything function. So the controller is like the main engine of the whole thing, and then these other 2 are tools that it uses to accomplish what it needs to accomplish. And the projectile is kind of the means of the end, really. All right, so hopefully that long-winded explanation helps you understand what I'm about to talk about next. So, jumping right in, this is my trajectory calculator script. So one of the first big things that I did that's different than the last video is I made this trajectory class, and this class is just a list of locations and directions. Whoa, okay. Just a list of locations and directions that we were handling independently before, and I didn't have a good way of sending a trajectory. Like, I didn't have a decent way of just like passing that around between different objects and classes, and now I do, because I have this class that is a trajectory class. It handles a list of locations and directions, which is really what I need for a trajectory. I could add more stuff in, like power and all that stuff, but I don't really need to do that. All right, so again, we have our public variables, which I already went over, so you can kind of see the default values here. And then which may or may not be off, like I start with 0 power and a 0.1 drag, even though I probably should start with a 0.05 drag, because that's what I'm using. And I should probably start with something like 60 points. Let's do 30 points. 60 is a bit much for default. Whoa, not 301. That'd be bad. All right. Start with a launch vector of 0, which makes sense. My gravity, again, is still set to 9.5. I'm going to change this to 1.25. And these are my new defaults. This is a pretty decent default setup that I found, at least for what I'm doing. Presuming that my power is never going to be higher than 2, this seems to work. All right. And then the only private variable, rather, is my trajectory that I'm going to be modifying as I go and generating all that stuff. So going right into this, I am going to clamp my points at 128. I don't want any more than that for performance reasons. If you start getting higher than that, then the line renderer starts to be really, really high poly, and the geometry, or sorry, the debug stuff starts to really tank the frame rate, and it really, really, it's a lot of calculations, and it's a big list, right? Because then we're gonna have an array here and an array here that are both over 128. So say 200. We'll have a list here that's 200 and a list here that's 200. I'm going to be passing that around and modifying it and things and doing collision checks. We do a collision check for every one of those segments. So we'll be doing 200, about 200 collision checks as well, which is just expensive. It's really, really expensive. In a 2D game, you don't need that as much. And if we were going to go... if we're going to have a really, really robust 3D game with a lot of collision checks and a lot of other stuff, I might actually disable that collision check and just let it be what it is and not do that. But for now, I'm doing it because it's a really simple scene and it accomplishes what I want. Might as well make it as high fidelity as possible, considering it's not really doing much. So anyway, yeah. So I clamp the points at 128 just for performance reasons. And then I clamp my launch vector at the normalized version of it. So that's kind of what I was talking about before, where I couldn't put in anything. So here, while this is running, if I try to do 1, 1, it doesn't let me. If I do 1 here, then it absolutely won't let me. And this is it's because this is how a direction vector works. This is a normalized vector, which is a direction. It just looks like this, and that's what happens when I normalize it. And the reason why I'm normalizing it is I want that to be a direction. I don't want it to be a direction plus an intensity, which is what like a value higher than that would be. That's all this normalize does. I hope that makes some sort of sense. But basically, if you want a direction, then you want to use this normalize. If you want a like an actual vector, like a direction plus movement, then you want to use a higher value than that. You'd want to multiply this by like 5, and that would be 5 units in that direction, if that makes sense. So this is 1 unit in that direction, which is a direction. All right. So if the first thing I want to do is I want to see if the power is greater than 0. If the power is greater than 0, then I want to think about maybe making a arc. And you can't make an arc with 2, 0, or 0, 1, or 2 points, right? You need at least 3 points to make an arc. So I check to see if we have at least 3 points. If we have at least 3 points and our power isn't 0, then we're good to go. We can start making an arc. So the first thing we need is our temporary variables. This is our starting values, and the values we're going to modify over the creation of the arc. So we have our direction, which starts off as our launch vector, and then we're going to create our list of directions, and we're going to set the initial direction point to be our temporary direction, which is our launch vector. So we're effectively setting up this list, and we're setting the first value of it so that we know we're starting off looking in this direction, and we're going to have this many directions. And we're going to do the exact same thing with the locations, right? We're going to say make a list and start that list off with the current position that we're in. And keep in mind, this script is going to be attached to the object that we're launching from. So if we wanted to do some sort of like this is attached to a cannon object, and then we have a muzzle object, which is what I usually do. We're going to do something like this. We're going to say public transform muzzle loc, and then in theory we would say that this, instead of being transform.position, is muzzle loc dot position, and then this would actually start the arc off at a different position that we can then manually set in game. The idea behind this being that if we had like a cannon, we wouldn't necessarily want the object to come out of wherever the center of that cannon was, or wherever the pivot point of that cannon is. We want it to come out of the barrel of the cannon, right? Which is in a different place than the pivot point of the cannon. But I'm not doing that because I don't need to, because what I'm doing is simpler than that. But that's how you would do something like that. Anyway, so starting off, just like we did our directions, we're going to say here's our list of directions. We're going to have it that many points long, or that many slots long, because that's how many points we want. And then we're going to set the base point to be the position that we're currently in. Yep, and then we're going to set our temporary power as whatever our starting power is, because the power is going to decrease over time, right? That's the drag. So yeah, and then we're going to say if we're debugging, we want to start off our debug raise. I'm not even going to really talk about debug very much in this video. I only have 5 minutes as it is, so I'm going to try to get through this. All right, so starting with our list, we're going to say, hey, we're going to loop through our locations. I could loop through directions, but I just chose locations of the exact same length, so it doesn't really matter. Yeah. So our temporary power is going to equal whatever the temp power is minus drag. We're going to clamp that value because we don't want our power to go negative because of drag. If we drag only works if something is pushing on it, right? We're talking about air drag specifically, like air resistance. If I push something forward, so if something is moving through the air and drag slows it down, it only slows it down to 0 and then it stops slowing it down. It doesn't keep pushing it backwards. So that's kind of what I'm doing here. I'm saying, hey, we're going to reduce power, the temporary power, by drag, but we're going to make sure that it's never less than 0, and then we're also going to the high end of it is infinity. We can have as much power as we possibly want for this calculation. We just want to make sure that it's never 0. That's all I'm doing. And then I'm also decreasing it by the drag. So our drag is like 0.05, I think. So if the temp power starts off at 1, then the next one is going to be 0.95. So we're starting off with that, and then we're going to say, hey, location, you are going to be our temporary direction, which in the first frame is our launch vector, times our temp power, which has been reduced by drag. And then we're going to add our gravity. So we're going to say vector3.down, which is -1 on the y, times our gravity. So we're going to go, we're effectively going in the direction of our launch vector, minus a little bit for drag, and then down some for gravity. And there's our second point, right? So we're going to set that as our second point. You'll notice that the for loop in this instance starts on slot 1 instead of slot 0, because I already handled slot 0 up here, right? So I don't need to start off on slot 0. I can start off on slot 1 and then I'll be fine. So yeah, that's kind of where I'm starting off. Sorry if I didn't say that ahead of time, but yeah. So yeah, then we're going to do the same thing with our direction. Our direction is going to be the normalized vector. Again, we're converting a position, in this case, to a direction, so we need to normalize it. And we're going to take our the location that we are moving to, and we're going to subtract the location that we're coming from, which in the first frame is our starting position. So this is how you convert a direction or a position to a direction. If you have, or rather I guess, two positions to a direction. So if you have two positions in space, in 3D space, you can create a line between them. Position 1, position 2, and now I can create a line. But if I subtract the target position from the starting position, then I get the difference between them. And that difference between them can then, through normalizing, be a direction. This is actually how Unity in their documentation for programming states to do directions, and it works really, really well. So this is we're using where we came from, where we're going to give us our current direction. This is going to be the direction that we're going to use on the next frame as well, to then determine our motorcycles. To determine our next location, because again we use temp direction here to determine where we're going to, but we modify that based off of certain values, right? So we're creating our temporary direction and we're storing that, and then we're done. Then we go to the next one and we say, okay, reduce power based on drag, offset the position and store that position based off of gravity and power and direction. And then we're going to say, hey, give me my new direction, and store that direction. So we're just going to keep doing that and doing that and doing that until we generate all the points. So don't want to beat a dead horse here, but let's talk about that real quick with an example. Point 1.6, please. Thank you. All right. So, and yeah. So again, we're going to, the magenta lines here are the directions that I'm starting off at. So this first magenta line is actually my launch vector, and the second one is my modified direction that I start off going. So like this cyan line here actually continues with this magenta line, right? And this cyan line continues with that magenta line, and so on, so on. The different positions are, this is my starting position, this is my first position. So this is the direction that I started going, and this is the offset of the gravity and drag. So you'll see that the end of this right here is a little bit less like on the X than this guy is. Here, I'll go in a side view here so you can see what I'm talking about. So see how the length of this line is a little bit reduced from the length of this line? That's our drag in action. So if I actually reduce the drag down, you should see that they are about the same length. This guy to this guy to this guy to this guy. But if I increase this to 0.05, you'll see that that line shortens a little. See? And that's the drag in action. And then the gravity in action is the distance from here to here. So yeah, that's kind of there's our different variables at work, right? Visually right there. So we're going forward along that axis, back a little bit because of the drag, and then down a little bit because of the gravity. And then we're going to do that again. And we're going to go forward, we're going to go down, we're going to go back. We're going to go forward, we're going to go down, we're going to go back. And we're going to keep doing that and doing that and doing that until we have created an arc. So it's that simple. Yeah. So that this whole for loop right here creates our arc. The next thing I do is I run that trajectory, because this is our current trajectory object that we have up here. I'm just modifying the positions or the locations and directions. I'm going to run that through my check for collision class, which is here. And what this guy does, it takes in the trajectory as traj, and it has a bunch of variables. So it has arch hit, false, it has my raycast hit variable, it has my call list at int, which effectively what I'm doing here is I'm going to run through every point in every location in my arch, and I'm going to do a raycast from it to the next point. And if I hit something, then I'm going to say, okay, this is where I need to cut off, is at the next point. So if I go from 0 to 1 and I don't hit anything, and I go from 1 to 2 and I do hit something, then I'm going to say 2 is my last point in the arc. Everything else after that is cut off. So this is my collision list, right? So I do a physics line cast from the first position to the second position, as long as I am in this list for as long as I have another point in the list, and as long as I haven't hit anything, using my collision mask. So as soon as I hit something, because this is an if statement, if I hit something, then I want to call the list at wherever I am plus 1. So I want to call the list in the next position. That way I don't cut the list short, because I don't want to do that. I don't want to cut my trajectory list shorter than I need to. And then I'm going to flag my arch as hit, and I'm going to draw a line just for debug reasons to where I hit from where I was. So yeah, after that's done, and I say if I hit anything, so if I didn't hit anything, then I'm just done with collision. I'm like, cool, I scanned the whole thing and I didn't hit anything, great. If I did hit something, then what I want to do is I want to reduce my location and direction lists. So this is locations up here, and then this is going to be directions. And you notice directions is a little shorter, and I think that's because, yeah, I explicitly say that the last slot in my locations list is the point that I hit, because I want my arch to be as accurate as possible. So if something in one leg of my arch, a leg of my arch being one of these cyan lines, right, like one of these guys, if something hit in the middle, I want that location where it hit to be the last point in my arc. So that's what I'm doing here. So I'm storing the entire list, or rather I'm creating a new vector 3 list, and I am making it as long as I need it to be. And then I'm going to go through for the length of this list, this temp list, and I'm going to add, I'm going to insert in my my locations from my trajectory that I'm inputting. And then that's it. And then after that, I'm going to set that trajectory list to be my new list, and then I'm going to make sure that I set that last point as the point that I hit. So I am effectively just ignoring the last chunk of my arch, and then I'm getting rid of it. I'm deleting that stuff. And I'm going to do the exact same thing for the directions, except I'm going to just ignore the last direction because it doesn't matter. And then I'm going to return that. I'm going to return my trajectory list. As you'll see here, I'm saying current trajectory equals check for collision because I'm exporting a trajectory from this. If I'm feeding it in, it's going to modify it and it's going to spit it back out based off the trajectory. And the rest of this is just debug stuff. I'm drawing lines. This chunk right here is what creates this visual, this cyan and magenta visual. So I have a draw line. This is the cyan lines. I'm just saying, hey, go from my position to the next position. And then this next one is draw a ray from each position out based on the power. I could have made this temporary power, so I could have visualized the power, but if that's the case, I would have had to include this whole debug in this for loop, which I guess I could. It's not that big of a deal. I had it in there originally, and I took it out because I was doing some test stuff. Let's do that. I took it out when I was still trying to do the subdivision crap that I took out, because that didn't work. That was a mess. So let's go ahead and put this in here, and we can say we can go from instead of power, we'll do temp power. So now when we come back in here, we'll see that these magenta lines are kind of shrink a little bit. Oh my God, that really changed things. Wow. Maybe we won't do that. Whoops. I'm going to ignore that I was doing that. I might fix that. If I ever upload this, I might fix that, fix this debug and put it in a different place. So just be warned. I don't know that I'm ever going to upload this. I still have no idea if I'm going to or not. But if I do, then this debug is going to be in a different place. It's going to be wrapped in this for loop, and I'm going to actually make that work. Sorry about that. Anyway. So that's our check for collision, and the only other classes that I have in here is get trajectory, get path, and get trajectories, which these functions might go away. I don't think I'm using them anywhere. I'm using this one to get the trajectory, because the trajectory is a the trajectory class that I'm having in here, is a private variable. So I need to do a get function in order to get it. I can't just say whatever object this is, or I can't say trajcalc dot current trajectory, because it's not a public variable. I did that on purpose. So I have this function here to get it. I have these other things here, get path and get directions. Basically, I should change this to get dirs, but I'm not using them anywhere. I can actually get rid of them, and it should still compile fine. I believe it will, and this should be fixed. Here's hoping. What is going on? Oh, okay. I am using those somewhere. Ugh, that's awful. I'm gonna fix that. That's a mess. Anyway, so that's gonna be it for this video. But I'm gonna upload another video right after this, and it'll be part 3, I guess, of this series, where I'm gonna talk about the controller and projectiles. Yeah, I hope this was helpful, and yeah, I'll see you in the next one. Bye bye.